Today's lesson is on piecewise function. A piecewise defined function is a function that is defined by more than one equation over a specified domain. So for example, let's say you have a cell phone plan that you pay $25 for the first 10 gigabytes of data, and then an additional $7 per 1 gigabyte data over that first 10 gigabytes. So there's two different rates going on depending on how much you use of your data. So if you only use less than or equal to 10 gigabytes of data, and we're going to let x equal the number of gigabytes of data that you use in a specific month, okay? So I have anything less than 10, and we should probably mention that it has to be greater than or equal to 0 because you can't have negative gigabytes of data that you're using in a specific month. Now, if that is the case, if you only spend between 0 and 10 gigabytes of data, you are automatically going to be charged $25. Now, you might go over the 10 gigabytes of data, and in that case, your x would be greater than 10, not or equal to, because if it's equal to, then you just get the $25 fee. So this is anything over. So you're going to still have to pay the $25 fee, plus you're going to have to pay $7 for every extra gigabyte of data. Now that's a little bit hard for some students to understand how we're going to charge that, because let's see, if I have 11 gigabytes of data, how much am I going to have to be charged for? Well, actually only one extra, right? Because the first 10 is already included in the $25. What if I do 15? Well, I'm only charged for the extra 5. Well, what if I have x, where x is greater than 10? Well, how do I get from 11 to 1? How did I get from 15 to 5? 11 minus 10 got me 1. 15 minus 10 got me 5. So x minus 10 gets me just the extra additional gigabytes after the first 10 are already paid for. So the expression inside the parentheses is going to be x minus 10, because that's going to get you just the extra one, okay? So this is our piecewise defined function. Depending on how much data you spend in that month will depend on if you use the blue equation to get charged just $25 or the green equation where you get $25 plus an additional $7 charge per data. So if I'm trying to find C of 4, I look at this 4 and I think, does 4 belong in our first domain? Is 4 less than 10 but greater than 0? Or is 4 greater than 10? Well, 4 is not greater than 10. So because 4 is in between 0 and 10, I use the blue equation and I just get C of 4 is equal to 25. This means if you have 4 gigabytes of data, you're going to be charged $25. Let's look at our next example, C of 15. Well, is 15 greater than 0 but less than or equal to 10? Or is 15 greater than 0? Well, 15 is greater than or equal to 0, so I'm going to use the green equation. So I'm going to plug in 15 into my equation. I have 25 plus 7 times 15 minus 10. And that's 25 plus 7 times 5, 25 plus 35, and that's 60. So C of 15 is equal to 60. What does that mean? That means if I use 15 gigabytes of data in that month, then I'm going to get charged $60. Okay, so let's go on to some more examples here. Evaluating a piecewise function at a value, which is exactly what we did when we found C of 4 and C of 15. But just to give you some more clearly defined rules, to find a function value with a piecewise defined function, you must first look for the domain. the function value belongs in. Then you substitute that value into the corresponding equation. A lot of students will try to plug it into both the first equation and the second equation and be like, I hope she picks the right one. Nope, you have to know exactly which one you are plugging into and only plug it into that. If I see on your test two values for your function, then I know you don't know what you're doing and they're both wrong, okay? So the first thing I'm going to look at is negative 3 less than 0, or is negative 3 greater than or equal to 0? I'm looking at the two function values here, and I am deciding which function it belongs in. So it looks like on this example, 3 is less than, so it belongs in the yellow function, okay? And the other one doesn't even make sense. Negative 3 is not greater than or equal to 0. So I'm only going to plug into the yellow highlighted function. So I have 6 times negative 3 minus 1, negative 18 minus 1, which is negative 19. So therefore, f of negative 3 is equal to negative 19. If you try to plug negative 3 into both and try to put both answers down, that's not true. For every x value in a function, you can only have exactly one y value. That's the definition of a function. All right, how about the next one, 0? This is a little tricky. Is 0 less than 0, or is 0 greater than or equal to 0? And this is kind of tricky because they're both zeros, right? But in this case, the blue one works because of the or equal. So the yellow one doesn't make sense. You can't be less than itself. You can be greater than or equal to itself. So we're going to plug it into the second equation. So we have 7 times x plus 3, but x is now 0. So that's 0 plus 3, or just 3. Therefore, f of 0 is equal to 3. All right, our next example, 4. So I'm looking at the domains 4. First, is 4 less than 0, or is 4 greater than or equal to 0? Well, it's greater than or equal to 0. So that's the blue function. So I'm going to plug it into the blue function. That's 7 times x plus 3, but x is now 4. So we get 28 plus 3, so f of 4 is equal to 31. This time we have g of x is equal to x squared minus 5 if x is not equal to 0, and 4 if x is equal to 0. So we've got not equal to 0 as a domain and equal to 0. This one is a little tricky for some students, so we got to discuss what or equal to or not equal to means. So is negative 3 not equal to 0, or does 3 equal 0? Well, 3 does not equal 0, so negative 3 is not equal to 0. So I'm going to go ahead and plug it into the yellow function, or the top function there. So I'm going to take negative 3 in parentheses and square it, minus 5. A thing people have a hard time with is negative 3 times itself. Negative 3 is positive 9, and positive 9 minus 5 is 4. Therefore, g of negative 3 is equal to 4. All right, our next example, 0. Is 0 not equal to 0, or 0 is equal to 0? Well, 0 is equal to 0. That's the blue one. So the other one doesn't make any sense, so you don't plug it into that one. So this one people have a hard time with. If x is equal to 0, there's only one number over here, and they think they have to do more than just writing that number down. But there's nothing else you can plug in, okay? There's no place that you can plug in 0. So if x equals 0, g of x is going to be equal to 4, period. That's it. So the answer is just g of 0 equals 4. No real work there to be done. You just got to figure out which domain it fits into. All right, now we've got 3. Is 3 not equal to 0, or is 3 yes equal to 0? Well, 3 does not equal 0, so that would be the yellow function. So we have on the yellow function, that's x squared minus 5, but instead of x, I'm going to plug in 3. So we have 3 squared minus 5, which is 9. 9 minus 5, which is 4. So therefore, g of positive 3 is equal to 4.